Problem 15. So values for A, B, C, and D are to be selected from 1, 2, 3, 4, 5, 6 without replacement, i.e. no two letters have the same value. How many ways are there to make such choices so that the number of curves y equals ax squared plus b and y equals cx squared plus d intersect? The order within which the curves listed does not matter. For example, the choices a equals 3, b equals 2, c equals 4, d equals 1 is considered the same as the choice a equals 4, b equals 1, c equals 3, d equals 2. So I think the nicest way to do this is to just, we choose A, we choose B, we choose C, and we choose D. This is the number of ways to choose A, B, C, and D. This is just like straight up. That's the first line. So let's just go through line by line and let's build this out. So values are to be replaced without any replacement. That's why it's 6 times 5 times 4 times 3 and not 6 to the 4th. Now, how many ways are there to make sure that the choices y equals ax squared and y equals cx squared plus d intersect? So we just like solve this equation. So ax squared plus b equals cx squared plus d, a minus cx squared equals d minus b. So as long as the sign of a minus c equals the sign of d minus b, and this SGN function is just like, it returns 1 if the number is positive and -1 if it's negative. It's just the way of saying, like, if a minus c is positive and d minus b is positive, or if a minus c is negative and d minus b is negative, then we'll always have a solution. It's like a minus c times x squared equals d minus b has solution if and only if the sign of a minus c is equal to the sign of d minus b. And this happens exactly half of the time. You can like show this by imagining, like, if you swap b and d, if you swap b and d, then the sign of d minus b also gets swapped because it's d minus b instead of b minus d. And so yeah, so having the intersection condition cuts it down by 1/2. And then we also have the final condition that the order in which the curves are listed does not matter. So that means that we have to divide by 2 again, because that means we're counting each curve twice when we choose A, B, and C, D. And then we just evaluate this, and this gets you 90.